Today we're looking at notes 5-8. These notes are going to help you with the lesson 5-8 discriminant. So I've made kind of a little web here about numbers as you know them and how they break up. So all numbers that you know either separate into one of these three categories. They are either real, complex, or imaginary. And within the real number category, you can have either rational or irrational numbers. So let's kind of give definitions to each of these. So a real number is a number that includes rational and irrational numbers, okay, not imaginary. So basically real numbers are any numbers that are not imaginary, okay? So what is a rational number, you might ask? A rational number is any number that can be expressed as a fraction p over q, where p and q are integers, meaning whole numbers. So for example, a rational number would be 2, -5, 4/5, because each of those are whole numbers, -1/3, those are whole numbers. 0.25 is actually a rational number because it can be rewritten as 1/4, and so 1 over 4, those are whole numbers. And -1.25 also, because that's -1/8, so that can be written as whole number over whole number. And also something like 0.6 repeating, because 0.6 repeating is the same thing as 2/3. Okay, and 2/3 is a whole number over a whole number. So basically a rational number is any number that can be written as a whole number over a whole number, and even can be positive or negative, doesn't matter. Okay, so that's a rational number. An irrational number is exactly what you might think, opposite of that. So it's any real number that cannot be expressed as a fraction. So when written as a decimal, what rational numbers do is they do not terminate, that means they don't end, nor do they repeat. So give me an example of that. Well, pi. Pi is a never-ending, never-repeating number when you write it as a decimal. Same for E. E is something we'll look at as we go further into the year. Also, your square roots that can't be simplified, like square root of 5, or even a negative square root of something that can't be simplified, like square root of 7, or 2 square root of 3, because the 2 has this square root of 3 attached to it. That is considered an irrational number because square root of 3 can't be simplified. Okay, so real numbers are either a rational or an irrational number, any of these numbers here. So your positives, your negatives, anything basically that's not imaginary. Okay, so that's your real numbers. Complex numbers really interesting. Complex numbers are a mixture of both real and imaginary numbers. That's why I put it in the middle. What do I mean by that? Well, a complex number is a combination of both a real number and an imaginary number. And it's written in the form a plus bi, where a is the real part, like that's the real number, and bi is the imaginary part. So for example, something like 2 minus 3i, that's a complex number. Also, -7 plus 6i, that's a complex number. So you've got your real part and your imaginary part, and they're connected. So this is a complex number, and this is a complex number. It combines a real and an imaginary number. Okay, and then last but not least, you've got your imaginary numbers. So you know what those are. Those are what we've been working with recently. Something like just this, just the 6i part, just the -3i part. Those are imaginary numbers. So make sure you get all of this down, go back, rewind, pause, do whatever it is you need to do to make sure you come to class with this little chart. It will help you with your assignment for tomorrow.